We are now live on the YouTube.
Right. Shortly, it was for 3 p.m. We have 4 minutes to go and we'll start.
It's 3 o'clock.
Okay. Hello and welcome to Compass 2021, brought to you by the Caucus, the Discussion Forum, and the Internal Quality Assurance Cell of Hindu College. I'm Shelly Birla, and I'll be your host for the day. A year into the pandemic, we have learned how to function within the four boundaries of our screens. Although it limited our mobility and to also some extent our functionality, the pandemic was not without its silver linings, especially for us students because it brought the student community much more closer to learning. Today, we are in conversation with Dr. Soumya Swaminathan, who is a pediatrician, a clinical scientist, and also the chief scientist at the World Health Organization. We'll be discussing the topic of India's scientific potential with her. For the information of our audience, I would like to add that this session is also being live streamed on our YouTube channel, and you can find us at Caucus Hindu College. So without further ado, I would like to invite our teacher in charge, Dr. Ravinandan Singh, to deliver the introductory remarks.
Right. Thank you. I warmly welcome Dr. Swaminathan, our eminent guest today, on behalf of the college's principal's office. Our principal, heartily welcomes Dr. Swaminathan. Because of some COVID-related emergencies, she couldn't join, but she would be glad to hear the talk later on herself. After the introduction that we just had, we don't need to add anything more. Dr. Swaminathan is well known, and her research work, her current position at the WHO, we look forward to hear, some of those details about her own research, but particularly with respect to the Indian context in terms of how do we begin to unlock the hidden scientific potentials into the contemporary, into the present, a present which is currently unfolding before us. Right, so, heartily welcome again, Dr. Swaminathan, and, we look forward to the talk that you're going to deliver. Thank you.
Thank you, sir. We are indeed very honored to have Dr. Swaminathan with us here today. So for our next segment, we have members of Caucus, Jivesh and Hardik, who will be delivering a short primer presentation for the convenience of our audience. So Jivesh and Hardik, over to you.
Good afternoon to one and all present here. Today, I, Jivesh and Hardik are going to present a brief insight into the topic of our today's discussion, unlocking India's scientific potential. India, since its ancient past, ranging from the discovery of zero to surgeries, rhinoplasty, and even Ayurveda, India has always been a pioneer in the field of science. Scientists and scholars such as Ramanujan, Dr. C.V. Raman, Homi Bhabha, and Vikram Sarabhai are to name a few. They unveiled India's exceptional scientific potential to the world. India boasts of a number of institutes indulged in research and innovation. Is one of the renowned centers for space, science, and engineering related researches. DRDO, with its vast innovative potential, has helped India to be at par with the world in the defense sector. After India completed the sequencing of the human genome in 2009, ICMR has made significant strides during the recent COVID-19 pandemic.
With ICMR as the center for research, the way in which we are combating with the global pandemic says much about our scientific capacities. Since the day India registered its first COVID case, our scientists are on their toes, carrying out research and vaccine development. The country not only emerged as the largest producer of COVID vaccine, but also did not hesitate to supply vaccines under its initiative Vaccine Matching. We also rolled out world's largest vaccination drive with the help of indigenous vaccine produced by Bharat Biotech. Investment in research and development is instrumental for scientific growth. Hence, it cannot be compromised. In India's case, 0.65% of GDP is spent on R&D, which stands very low when compared to 2.1% by our neighboring China and 2.8% by the technologically advanced USA. The recent economic survey also highlighted this fact. The survey is critical of the contribution by India's business sector. It stated that while the government is already doing the heavy lifting, it's India's private sector that needs to rise to the occasion and significantly ramp up its gross expenditure in R&D. Among the 131 countries assessed by the Global Innovation Index, India is ranked 48, moving up 4 spaces since 2019. However, in the lower middle income group countries, India occupies 3rd position, whereas Vietnam leads owing to its developed infrastructure and ease of doing business. Also, due to the exceptional quality of its institutions and high expenditure on R&D, China consolidates its position at 14th rank. While assessing India's potential in science, these are the questions that face us. With the hope that today's discussion will help us find new ways of increasing India's scientific prowess, we thank you for listening to us.
Thank you, Jivesh. Thank you, Hardik. Now, on to the much awaited part of our discussion. I would like to invite Dr. Swaminathan to deliver her remarks on today's session.
Thank you. Thank you so much, Shelly and Hardik and Dr. Ravinandan and all the students who have organized this function today and invited me. I don't know if you know, but I am an alumnus of Hindu College, which is why I prioritize this talk over so many other invitations that I get. So I did my first year zoology honors in Hindu College after finishing my class 12. In those days, school was 12 years, 1975. And actually my intention when I joined the Hindu College was to actually complete a BSc in zoology, go on to do an MSc and a PhD. I was interested in pure sciences. I was interested in biology, in genetics, and my goal was really to be a scientist and a researcher. It so happened in those days, everyone who was in first year of a science subject was actually aiming for medicine. So it was what was called a pre-med year. And almost all of my classmates were going to take the medical entrance exams at the end of the year. So I just, I guess, got influenced in some way by talking to lots of people. And I said, okay, why not? Even though I was actually firmly focused on my path. So I did a medical, and I took only one medical entrance exam, only one. And that was the Armed Forces Medical College, because I had spoken to a few senior students and I felt that the environment in AFMC would suit me well. So I went ahead and took that exam thinking that I would not get through, and so my future would be secure in the pure sciences. But then, as fate would have it, I cleared the entrance exam and the interview, and I was selected for the AFMC. And then a lot of seniors and mentors and advisors said, this is not an opportunity you should miss. Do medicine and then continue with research. Having that background in clinical medicine would only help you with your research in genetics or whatever area you decide. So right from an early age, I wanted to pursue research, and that's possibly due to my exposure in childhood. As you may know, I grew up in the Indian Agricultural Research Institute. I was surrounded by students, masters and PhD students who used to come home to discuss their research with my father. I would go to the labs on weekends. I was fascinated by the laboratories and by the experimental fields where these experiments in breeding new varieties of wheat and rice were going on at that time using the scientific methods of the day. And I also was very interested in biology. I did, when I was in class 10, I did a science talent scholarship summer project where I spent 2 months with a very eminent scientist, Dr. Archana Sharma. Unfortunately, she's no more, in Calcutta. And what I did was she took me to the clinic in one of the hospitals in Calcutta where I saw a patient with a very rare phenotype, a girl of 16 who had amenorrhea. She had not achieved puberty and she had certain features, physical features, which suggested a particular genetic chromosomal abnormality. So we drew blood, went to the lab, and then I was tasked as a 10th class student with doing the karyotyping of the chromosomes. At that time in 1973, 74, it was, we did not have the modern genetic methods we have today. But it was so fascinating for me. I karyotyped, I laid out the chromosomes, 23 pairs, and found that this unfortunate young girl had only one of the X chromosomes instead of two. And it's a syndrome called the Turner's syndrome. It's X0. So it's a genetic disease which has infertility and phenotypic typical features. And probably it was something there also which really ignited my interest further in science and research, because I felt here you see something in the clinic, you can describe what this person has, but you really don't know what the underlying cause is. Is it genetic? Is it environmental? Is it something else? Is it a combination of the two? But then you have the technology available to you to make further investigations and find out the underlying cause. And unless you know underlying pathways and causation, you cannot think about treatment or prevention. And that's where, genetics and genomics today is at a point where it's offering us the unimagined possibilities to deal with human health. It's not only genetics, but epigenetics as well. And the fact that we can now manipulate very much more in a targeted way, in a very sophisticated way, using gene editing, which of course got the Nobel Prize. As you all know, that Emmanuel Charpentier and Jennifer Doudna won the Nobel Prize for their invention of a CRISPR technique of gene editing, something that they discovered when working with bacteria. It is a naturally occurring phenomenon, which they discovered and put to use to edit now human genome, to the point where not only for diagnostics, but for treatment of diseases like sickle cell, thalassemia, and other inherited disorders, it is now possible to think about gene editing. And at the WHO, we're very interested in developing a governance framework for this, because you've also heard about cases where gene editing has been used in unethical ways to do experiments on embryos without really thinking about all the future implications. So just want to make the point that technology today, from when I was a student and I was doing my school projects, and the kind of projects probably that you all are doing now, is very different. But the fact remains that all technologies, all advances come with the possibility of doing immense good, but also the considerations of social and ethical and legal implications must always go hand in hand. We cannot blindly use technology for all, and this is from the invention of fire to every possible technology that we can think of, whether it's nuclear, it can be used for nuclear peace, for energy, it can also be used for devastation. Similarly, artificial intelligence can be used for a lot of positive reasons or applications, but can also be used, for doing things which are unethical and inequitable. So we need to consider always those things. And so the WHO, as part of the science division, I have initiated this work looking at the social, ethical, legal implications of cutting edge technologies like artificial intelligence and genome editing. And we will be coming out with some reports this year. And every country, every government, every research institution needs to think about it. In fact, this is something now that's really that's come up also for discussion when we think about the pandemic and the fact that there's been a lot of debate about how pandemics could arise. Where could organisms that cause epidemics and pandemics arise from? And one possibility, of course, is that they come from nature, and that's the most common. Zoonotic pathogens which circulate amongst animals and birds, which may not necessarily be harmful to them, but when they make a species jump to humans, they often undergo certain mutations in order to adapt to living in the human host, and that very often the human host does not have any exposure to these pathogens, and therefore the disease can be quite serious. Most of the epidemics we've seen in the last few years have been zoonotic pathogens, whether it is Ebola or Zika or even HIV, as well as SARS-1, MERS. These are the other two serious coronavirus infections that humankind has been exposed to, have all been zoonotic, from zoonotic origin, and they all occur because we have interfered with the environment, that we've interfered with biodiversity, that there is illegal trade in wildlife, where people are coming in close proximity, or creating environments where domestic and wild animals can really mix very closely, as they do in these so-called live wet markets, where viruses can easily jump across from one animal species to another. So a lot of this is human-made, just like the other big threats facing us today, which are climate change, as well as the specter of antimicrobial resistance. So while we're all focused on the COVID pandemic, the fact is that climate change, as well as antimicrobial resistance, are phenomenon which are slowly impacting our lives, and they're not dramatic like the viral pandemic today, but they're going to have huge, huge impacts on us, on you all, and the future generations, unless we make change now. And that is where I think the topic of today is very relevant, because when we talk about what science can do, and again, my experience as a chief scientist at the WHO over the past year has been an incredible scientific collaboration globally, where there's been absolutely no hesitation on the part of any scientist from any country, public or private sector, to collaborate, to cooperate, to share knowledge openly, to not wait for publications, to really advance knowledge as quickly as possible in order to achieve the goals that we all want, which is ending the pandemic. The development of new vaccines, therapeutics, diagnostics has gone hand in hand with the understanding of the virus itself, how it transmits, where did it come from, what is your animal origin, how do you prevent it, what are the most effective ways of infection prevention and control, etc. So we took the lead early in 2020 by organizing this Global Research Innovation Forum. And since then, we've worked with these expert groups of thousands of scientists literally around the world. So I think that science has delivered. And why did it deliver? If you take the example of vaccines, how come we're so successful when in the past it took a minimum of, 5 years is the record for any previous vaccine development. I think mumps was developed in 4 years, and Ebola took about 5 years. But again, there was a lot of work done prior to that. This time around, within a matter of 11 months, we had, from the discovery of a new pathogen and the genetic sequences that were made public on January 10th by the Chinese scientists, the first 6 sequences became public through a public database called GISAID. In November, we had the authorization of the first vaccine. Incredible scientific achievement. Why was it possible? A couple of reasons. All the investments made in science and technology over the last decade or so, developing these platforms, the mRNA platform, 30 years people have worked on it. The scientists who worked on it 30 years ago could not imagine that this would happen. They had a lot of uphill battle and struggle. Their research was not funded. But for 30 years, some people persevered till we had the platforms ready for any new pathogen. And so they were very quickly able to take the sequence, put it into the mRNA platform. Similarly with the adenoviral platforms as well, make the vaccine. Scientists made the vaccine in the lab. Then the clinical trials had to be done. This is where public and private sector collaboration helped. Operation Warp Speed, which is the most successful global project to develop vaccines, essentially pumped a whole lot of money into the private companies to develop these vaccines, to scale up manufacturing, extremely important, to set up those facilities to make hundreds of millions of doses, that's not normal, and to run the clinical trials in the networks that had been set up by the NIH for other diseases like HIV. Those were quickly mobilized so that clinical trials were run in record time without compromising on safety or efficacy. Very often people think that some shortcuts were taken. It's not true. What did happen is that the regulators worked very closely, again, around the world with the WHO to define what are the benchmarks that need to be met, knowing that this is an emergency, that you cannot wait for years to approve vaccines. You need to have certain benchmarks where you do not compromise. And then you put in place a system where you continue the monitoring, continue the development of knowledge, even while vaccines are being rolled out. So that's what's happening now. You have this emergency use authorization by regulators, which allow the use of vaccine. At the same time, data is collected. And if you learn new things, you have to act on it. That's why safety signals which are picked up are being investigated, as well as post-introduction studies are being done on effectiveness against the variants, and so on. So research has to continue. So the point is that investment in basic science will only pay off many years later. You cannot predict when and where and in what form the investment is going to pay off. So for young people, I think the lesson here is, if you're interested in a topic, if you find a research question that's really very interesting and that you're passionate about, where new knowledge needs to be created, you need to pursue that. And of course, you need a system which will help you to do that. You need an institute with facilities, some research funding, but it's important to get deep into a subject and become an expert at that, rather than trying to do everything and not have domain knowledge and expertise. So the government is investing much more in science and technology. There's a new policy out there. There's a National Research Council that's being set up to fund research, mostly in the state universities. It's very good because that gives students an exposure to research, which otherwise does not happen in most of our colleges. In fact, even when I did my postgraduate training in India, I felt that my exposure to research methods was inadequate. And it was only after I went to the US for a fellowship following my MD that I really felt that I learned research methods and statistics and how to ask the right question. And when I look in India and look around at people who are doing their PhDs or their masters, most of the questions that students are asking are not really fundamental research questions. And that's partly because of the difficulties of time and resources, and the fact that you have to finish your thesis but the quality of the work, especially at the PhD level, really needs to be improved at most universities. Of course, we have outstanding universities with outstanding research output, but I think this comes very early in a student's training. It starts usually in school, and in the undergraduate, you learn how to ask questions. So we have to move away from the system where we read textbooks and we try to just learn that knowledge, rather moving to a way of asking questions and answering them, where you learn by doing and you learn by experimentation. And this is something I think that it's very important, because it's the way in which you then approach life in general. So one is the art and science of asking the right question. And secondly, then you, of course, need some training to understand what methods that you want to use to answer that question. So this is where the understanding about statistics and basic concepts. For us in medicine, it's about understanding epidemiological concepts, statistical concepts. When you read a paper, you should be able to evaluate whether that quality of that paper is good enough for you to believe the results. So if somebody does an experiment in 10 people and writes a paper about it, it is probably not generalizable, you know, immediately. Or if there's a study done which is just a descriptive study, you can use it to generate hypotheses, but you can't use it to make conclusions. So those are the kind of things that you learn when you start understanding research methods. And so this is where education becomes very important. And I think, you know, the whole relook at the national education policy, the science, technology, innovation policy, the National Research Council, all of these are going to be very critically important to shape the future minds so that we become a more questioning community. There are, of course, many more opportunities now for young people to take careers in science than they were in the past. When we were growing up, you know, there was essentially engineering and medicine were the two big streams. There wasn't that much opportunities for basic science or any kind of glamour around basic science. But if you look at people who win awards and prizes around the world today, even if it's a Nobel Prize in medicine and physiology, it usually goes to people who've uncovered a basic physiology or a pathogenesis or a mechanism of a disease, or how certain elements of the human body function, you know, whether it's Venki Ramakrishnan and the ribosomes, or whether it's the gene editing award. It's about, and I'm reminded of my college days when I learned biochemistry and pharmacology, but really without linking it in the way that probably we should have done to human disease. And when I meet medical students now, even those who are in their first year or second year, they are learning about biochemical pathways and molecular mechanisms in a way that helps them to understand disease. So this is also linked, of course, to scientific literacy and health literacy in the population at large, because I think good science education, everybody doesn't have to be a scientist. Every student doesn't. In fact, the social sciences are equally important as the natural sciences. Physics, chemistry, biology, mathematics, as important as the social and behavioral sciences, anthropology, psychology, etc. And that's something, again, that we haven't paid a lot of attention to. When we talk about science, we only think about the life sciences or natural sciences. We don't think automatically of social sciences, and they don't have the same level of respect and prestige. So that also is something that we need to change, because that is so important. I think for all the things that I mentioned climate change, I mentioned antimicrobial resistance. You can take any of the sustainable development goals. None of them can be achieved without a few things. One is a good community of people, scientists who understand, have the domain knowledge and expertise. So that's really important. Get your domain knowledge first. Decide what you want to do and be the best at that. And if everyone does that, then you have a whole community of people who know exactly what they're talking about. The second is interdisciplinary and transdisciplinary collaboration, also very important. And we've seen now, if you look at papers in Nature and Science, you'll find 150 authors, sometimes more. Those are the kind of papers that make big discoveries. They're all interdisciplinary groups. And then the third thing, of course, is to think about the problems that one wants to solve. And again, it needs an approach. And this is, again, a lesson that I've learned through my life, is that a top-down solution usually is not the one that's going to work. If you identify a problem, you then need to find a solution by really talking to the stakeholders and to the community and the people it impacts, as well as a lot of others who have domain knowledge. And then jointly you try to find a solution. This is my life. As you know, I spent most of my life doing research on tuberculosis, HIV, both in adults and children. And through that experience of meeting patients with TB, their families and communities, and by traveling into those rural areas, tribal areas, as well as urban slums where most of these patients come from, I got a good understanding and more of empathy, I should say, on the other determinants of health that impact people or other determinants of the quality of life. It's very easy for a doctor in a clinic to scold a patient, and I've done that many times, for him or her not taking their treatment, not taking their drugs, not coming for the regular appointments. But when you then go to that person's home, living in a very small hut by a very dirty nala somewhere with 3 children and a family to feed, and that person is let's say a daily wage laborer, he or she has to choose between earning their daily wage to feed the family and going to the clinic to take their medicines or to keep their medical appointment. So sometimes you have to put yourself in the shoes of the other person, and that's where I think the kind of exposure that one needs, even as a scientist, you need to go down into the field and to look at the problem that you're trying to solve. And when I used to go to villages when I was a much younger scientist and tell people, okay, I've come here, this is the problem of TB, we need to get together to solve it. And the villagers would say, well, you've come and you're talking to us about TB. Maybe that's a problem we see once or twice a year, somebody in the village gets TB. But we have much more common day-to-day problems. And why are you not talking about them and helping us to solve them? Here's the quality of our water, which gives us fluorosis. Look at our children, look at the teeth, look at the bone problems we have. It's all because the quality of the water. And we don't want, but we have no choice. So, or, they would talk about not having safe sanitation for girls, particularly in schools. Of course, all that is changing now because of the Swachh Bharat mission and the focus on sanitation, menstrual health, etc. There are very fundamental problems that are not talked about. In my visits to tribal areas, for example, when I meet young people there, I really feel that there is so much of opportunity, there is so much energy that they have, so much they could do, but they don't have the opportunity that perhaps children growing up in the urban environment have in terms of education. And therefore, they drop out of school, they take up other things, they elope from, they take to alcohol, and all of that is because of the lack of other productive opportunities. And whenever I have been able to discuss some options with those young people, boys and girls, they would be delighted actually to have an educational opportunity of training as a nurse or a teacher, and then going back to serve their own communities. So we have, I think the other lesson for me really is that science and technology always has to take into account. I mean, we talked about the ethics, but the other aspect is equity. And if technology is going to help only people who are already privileged and leave out the rest, then that goes against, I think, the very principles of what science should be doing and research should be doing, which is to solve the problems of society and of humanity. And I think if you look at vaccine, it's very stark today that you have 850 million doses of vaccines that have been given to people around the world today. I'm talking about COVID vaccines. Less than 1% of population in many African countries and many low-income countries. 1 in 4 people in high-income countries have been vaccinated as opposed to 1 in 500. You look at the contrast, 1 in 4 versus 1 in 500, despite the fact that we've been talking about vaccine equity for the last 1 year and encouraging countries, companies, manufacturers, donors to really think about equity, because unless everyone is safe, no one is safe, and something like a pandemic cannot be handled a country at a time. So again, the big global threats like climate change, antimicrobial resistance need global collaboration and solidarity. They cannot be handled a country at a time, even though every country needs to cooperate and to set their own policies and guidelines. And the same is true within large countries. You have inequities between countries, but also within countries. And so when we think about any technology, I often think about digital technology, online teaching, and the fact that so many children do not have the opportunity to do what we are doing today. We are interacting, we are getting on with our lives, we are able to function, but not everyone is able to. And this is where I think the democratization of science, the benefits of science and technology are extremely important. And I hope as young people that you will keep that in mind in your careers and make sure that those benefits go to people. And I think that's what India has been very good at. India has always brought affordable solutions which make it possible for equity. Look at HIV and where we were before the Indian generic manufacturers took on the challenge of making antiretroviral drugs from $10,000 a year, the treatment cost dropped to $100 a year, making it affordable for people all over the world. So there are many such examples. And in the last 1 year, I think India has done very well in innovation, in making sure that we have our supply chains are built, that we are able to manufacture affordable diagnostics. We have so many innovative Indian vaccines in development. So it's been a pleasure really to see how Indian science has risen to the challenge, but we have many more challenges ahead. And so I think good lessons from the pandemic really need to be learned on the whole ecosystem of science and how that can help to solve the country's problems and ultimately, of course, the world's problems. So I think I will stop there and turn it back to the moderators for the rest of the session. Thank you.
Thank you, ma'am. I would now like to invite members of caucus, Shabdita and Arnav, to commence the moderated session.
Good afternoon, ma'am. I think that was a great speech, and I personally have a lot of questions to ask. I am Shabdita, and I am a student of history at Hindu College. I'm in 3rd year, and my co-moderator Arnav, please go ahead with your introduction, and then we'll begin with the.
Good afternoon, ma'am. Ma'am, that was indeed a very great speech. I believe we all of us have great takeaways from it. My name is Arnav, and I am a final year student of physical sciences at Hindu College. So, ma'am, before I begin with my question, I would just like to remind our audience that you can put in your questions in the Q&A box, and we will be taking your questions in the last segment of this discussion. Ma'am, coming to the question, ma'am, in countries like UK and USA, the best research is done by universities, MIT, Stanford, Cambridge, Oxford, so much so that the AstraZeneca vaccine is the Oxford vaccine. And the pure research institutes are limited and undertake very less research. But in India, we are doing the diametric opposite. Our universities are structured towards rote learning, and our research institutes such as the ICMR, the CSIR, the ICAR, the Institute of Virology, bear the burden of research. Ma'am, according to your wisdom, ma'am, which is the best approach towards achieving scientific proficiency? Ma'am, is it teaching hand in hand with research, or ma'am, keeping these two separate?
Yeah, that's a really good question. And I think, it has been addressed in the policies I talked about. I think Dr. Vijay Raghavan often, the principal scientific advisor to the government of India, talks about these issues a lot and why we need more research in universities. You're absolutely right that just doing research in the research councils and institutes is not enough for a country like India. A lot of knowledge comes from bottom-up research, and the more you have going on, the more chances we have for really good ideas to come up. So I think the idea of the National Research Council that will fund universities, particularly state-level universities, but it also, of course, means that you need faculty that are trained. And I think now we have a lot of opportunities through digital. There is no reason why we cannot have links between faculty in the eminent institutions in India and state universities, more partnering, etc., or even globally. I think science has to be global, and while ideas can come from anywhere, really. So there are, I think, we shouldn't look at it as a dichotomous. But your other part of the question is, I always felt that to be a good researcher, I need to be in touch with the ground reality. If I keep on doing research in an ivory tower, I may not be the most useful person around. And that's why I felt that having an opportunity to do teaching, clinical care, and research would be the best combination. And that's the kind of environment I was looking for when I came back after my fellowship to India, because I saw in the US universities that you could do that. You could have a research grant. Of course, it's competitive. You have to write grants. You have to get the grant. But once you have a research grant, you have some dedicated time for research. You spend dedicated time on the clinical wards so that you're seeing patients and you're not out of touch with clinical medicine, and you're teaching students. I think teaching is always very good to keep up your constant your learning as well. You have to refresh your ideas. You have to read if you have to be a good teacher. So ideally, we should have structures which allow us to do all the, at least teaching and research. If it's a medical research, I would say that you also need to be in touch with patients and with, because that gives you an insight into what are the important questions that you want to answer. So in the case of other disciplines, it may not be the same, but I think teaching and research going hand in hand is really a good way to proceed.
Right. Thank you, ma'am. Ma'am, my question is with regard to the immense potential that India has in terms of its population to unleash more scientific development. At the same time, about 8 lakh students from India go abroad to pursue higher education every year. How do you think that India can arrest this kind of brain drain to actually make use of the full potential that the population of India beholds, given that such a large amount of students migrate to other countries every year to pursue further education and research opportunities?
I don't think there's anything wrong with people going outside the country to pursue education and research. I did the same. Of course, what you need is the opportunity to come back and continue your career. And I think many would like to come back. And at 1991, when I came back, there were very few doctors who went abroad who came back. But that's all changing now. And it's the same in the other fields of science. So what you need is to create the opportunities, the infrastructure, institutions which can attract good people. And I think we've done that to some extent. We've created the ICERs and some of the other lab networks that we have. We're building more, high quality universities. So there are now, and we have fellowships for returning scientists, from the DBT, from ICMR, from CSR. There are grants that you can get as a returning scientist for 5 years to set yourself up and make sure that then you are competitive. We still have fewer, I think, than we need opportunities for young people to come back. But I think it's going in the right direction. So I don't think we should be worried about brain drain, but rather we should be thinking about brain gain. How do we bring those people back? And China did that. They set up institutions and gave very attractive offers to their citizens to come back and build institutions and departments within the universities in China. So it requires investment, of course, and I hope that we'll be going in that direction.
Right, ma'am. Ma'am, during your speech, ma'am, you made a mention that right after the genome sequence of the virus were released, there was a very less time span in between which the mRNA vaccines were released and got an authorization. And you said that scientists have been working for the past 30 long years. Ma'am, my question is, over many years in India, we have seen that only when a crisis stares us in the face that we start building up potential in that particular field. For instance, India became the center of vaccination production when the pandemic was almost out of our hands. Ma'am, how justified is it for scientific potential in India to remain dormant under normal circumstances? And do we always need a constant crisis at our doorsteps? And we have to live by the old saying that necessity is the mother of invention?
Well, a crisis always pushes you to do things faster and, quicker and more collaboratively. And it forces certain things to happen which don't happen when there's no crisis. But I wouldn't agree that India doesn't do anything till there's a crisis. I think over the last at least decade or two, we have seen consistently the recognition of the importance of science and technology and investing in institutions. When I was at the ICMR, we set up the Tuberculosis Research Consortium, which was basically a consortium to bring together all the science agencies and the private sector and civil society to work together on solving the problem, identifying the gaps in knowledge and seeing how everyone can contribute to the problem of tuberculosis, right from data, from developing new diagnostics, but also looking at, behavioral science issues and so on. So there have been other such national programs that have been launched, I think, for, artificial intelligence, cybersecurity, and so on. So space, we've done very well in many areas, but there are many more fundamental problems that are left. And sometimes I think we don't see the problem because it's part of our day-to-day life. I always felt that TB was invisible because it's been there forever. And most people don't know that, 500,000 people die of TB every year, year after year after year in India. Globally, we lose about 1.5 million people due to TB. Some other disease, which is more dramatic, it takes the front pages of the newspapers always. Similarly, the problems of sanitation, of garbage disposal, etc., which actually can lead to epidemics, which can lead to, these pathogens spreading across, which can lead to antibiotic resistance in the water, the quality of air. These are all things that impact health in big ways. And so the other issue is, I think, not really thinking only about solving the problem once you have it. Like you said, you have a problem, then you try to attack it and find a solution, but really working more upstream to say, how do you prevent that from happening? How can we move towards having better quality of water, better quality of air, which will have an impact on all citizens without waiting for the crisis? So I think thinking a little bit differently and maybe shining the spotlight on issues that we sometimes just take for granted, or we think that nothing can be done about it. That's where I think we can start making some transformative change.
Ma'am, my last question is with regard to a statement that you made that there is a need to inculcate more curiosity among the students and encourage them to ask the right questions. Similar to that, the Constitution of India also talks about developing a scientific temperament among its citizens. So my question is somewhat interdisciplinary in this nature. I wanted to ask, how do you think do Indian traditional values and culture sort of encourages this scientific learning within the country? Is it more of an encouraging factor, or does it pose as a hindrance to more scientific innovation and learning?
No, I wouldn't say that it's a hindrance, because actually, if you look at some of our traditional practices, they had some common sense behind it. And even though the scientific principles we discuss today are different because our understanding is different, the tools we have are different. But at the same time, when you think about the principles, whether it's applied to health or nutrition or other agricultural practices, they have some underpinning of science, behind them, even though they may not have been articulated like that. And I think we have to learn how to use our traditional beliefs sometimes to change behavior. You can go back to culture and tradition. And the most effective communicators of behavior change are those leaders which people believe in. Sometimes they are religious and spiritual leaders. Sometimes they are community leaders. They are the people who people trust. So we need to work with those institutions in India to have an impact. But at the same time, as I did talk about scientific literacy and health literacy, we need to move away from superstition to again, it's a questioning mindset that we need, not believe everything blindly. And with social media now, we've seen what we call the infodemic. So WHO coined the term infodemic. Along with the pandemic, you have this overabundance of information. A lot of it is incorrect or even false, misinformation and disinformation campaigns, conspiracy theories that go around on social media, which people tend to believe very easily. So that's the kind of thing we need to counter by saying, before you believe something and forward a message on WhatsApp, just stop to think and verify. When you read something, it's not automatically true. And that's where your scientific mindset comes in. And you don't have to be a scientist, but you just need to be somebody who thinks rationally and who questions things and see, is it plausible, before we believe. So it's, I think it's to do with education and your exposure. But it's also now, I think, much easier, as I said, because of, well, in a way it's easier. You get exposed to a lot more now through digital means, but it doesn't mean that everything you are being exposed to. And, there's a whole theory now that social media can influence your thinking because they understand, the algorithms understand you and what your beliefs are, and will keep on feeding you with information that goes along with your beliefs. So if you're a person who does not believe in vaccines or is hesitant, you will be fed more of that kind of information. If you're looking for pure science and reading the scientific literature, you'll probably get much more of that coming up in your feed. So I think one needs to recognize that social media can have the algorithms that underlie it will have an influence on you without your realizing. It can really affect the way that you think. And as long as you're aware of that, it is okay. But if you are unconscious of that, then your biases will be perpetuated. So I think also much more discussion and debate in society about some of these issues is important. Transparency, discussion of data. I think all of this helps really to build that scientific temperament in society.
Right. Thank you very much, ma'am. Thank you for answering our questions. I will move on to the next part of the discussion, which is the preset questions. We received a number of questions via the registration forms as well, and we have chosen one particular question. I will read it out now. The question is from Soham Agarwal. He's asking that India is a growing superpower in the world. The country has produced a lot of the best brains in the world, but still we do not have many Nobel awards in the field of science. How do you see this dilemma?
Nobel Awards is one way, of course, of assessing the output of science and where we are globally, but it's not the only one. In fact, if you look at Nobel Prizes won by Indians, there are several, of course, many of them have won them while they have been outside the country. So again, that's the opportunity that we are now creating, I think, in the country for not only education, but also to continue with your research career in an environment which gives you that opportunity to do the cutting edge research and cutting edge science. But, if you look back 50, 70 years, people won Nobel Prizes, C.V. Raman and others, without having very much. So I think it's the ideas that matter. But today, of course, technology is important to be able to test your ideas. So we do need that infrastructure and the environment, which should not be a stifling and a bureaucratic environment, but it should be an environment which allows you to explore. And that's why I think basic science investments are important, because they don't give you the results right away. You cannot have an impact. You cannot always be producing a vaccine or some product at the end of every piece of research, but advancing that knowledge. And we've done very well, I think, in physics and mathematics, in theoretical physics and mathematics. I think Indian scientists are really at the leading edge globally. But where we need more, I think, because those don't need that kind of infrastructure. You need computing facilities, of course, high-powered. But for other kinds of research in the natural sciences, in life sciences, you need much more technological facilities available, genomics, for example, or large data sets. So there are certain things for creating a research ecosystem which will need collaboration between government and private sector. The government needs to set the regulatory boundaries. It needs to set the governance principles. It needs to have things like, the principles behind data sharing and data management, and provide opportunities for the private sector also to invest and contribute. The private sector in India needs to do much more in terms of investment in R&D. So encouraging those collaborative, where the government takes some of the risk away. That's what happens in the US, where the government investment in research takes some of the risk away from the private sector, but ultimately it's a private sector that drives the innovation and then of course also gets the rewards. So we need to think of a system. I wouldn't say that we have to copy that entirely, because we do need to think of an R&D ecosystem which has inbuilt some equity and access principles. We can't invest in things using taxpayer funds where the profits all then go to the private sector. There has to be a give and take. And if you are investing in something because it's a public health need or a public good, then we need to make sure that the private sector is de-risked and gets that investment. But then when they develop the innovation, that it's then available for the benefit of people, while at the same time they get back their costs. So globally also one is thinking about this, but of course it's a very complex topic, because all countries do not agree on this framework where R&D is linked to equity and access. But certainly it's a model that India could set a new path in.
Right. Onto the live questions part. The first question that we have is from Nitya Agarwal. She's asking that about half of the Indian girls between the age of 15 and 49 are found to be anemic. We have a serious condition of malnutrition in India, as 14% of the Indian population is undernourished. The ICDS program is also failing in the current times. So how can we expect a brighter future in this regard?
Yeah, I think this problem of anemia and malnutrition is really, really important. So I'm glad that she has raised this question. It's something that we haven't really made a big impact on, despite all the programs that we've had, including the ICDS. So we really need to ask the question why. So this is where I think good interdisciplinary research, really going in depth into the data, trying to understand get to the root of the problem. Why has anemia persisted despite all the problems? And I think we don't know the answer to that. So this is where we need to apply all the cutting edge research methods we have and do the interdisciplinary research to answer those fundamental questions. Is it related to a lack of intake of iron and other micronutrients? Is it related to absorptive capacity? Is it related to some other factors which are impeding the formation of hemoglobin? How much of it is genetic hemoglobin disorders? Unless we understand that, there has been, of course, work looking at a higher level, I think, at the factors like education and income, which are linked with anemia and malnutrition. But I think we need to drill much deeper down, and then the solutions will have to depend actually on what we find. So I think it's a really good question and a very good area for further work and research, because this is going to be one of the major issues that will impede India's development. If we do not solve our malnutrition problem, then, as you know, malnutrition in childhood is linked to brain growth and development. So it's directly linked with human capital. And if we have still over 25-30% of children who are stunted, it means that their brain development is also impacted. These are the future citizens of India. So it's an incredibly important issue. I would put it as, in the top few issues that need to be researched in order to find the solution. So thanks for that, raising that question.
Right. Ma'am, this question is from Gunjan Roy, and this question is with respect to all the Indian students. Good afternoon, ma'am. With reference to the contrast of scientific education you highlighted between our country and abroad, what do you suggest we can do on a personal level to achieve the degree of academic competency most students are exposed to the education system outside have, so as to get engaged more into the quantitatively stronger side of academia?
So this is where I think now it's much easier for students just because, of the opportunities you have for online learning and the number of universities that offer courses, both free as well as paid courses, Indian universities and universities abroad. So I think there are a lot of opportunities for students now to learn about things which you normally would not have learned if you had, in your own undergraduate or postgraduate program. You can really enlarge your minds now, actually. You have to spend more time, of course, and some of these, as I said, may be paid courses, so that may be a limitation. But I think that today, because of this online tech and digital technology, you actually have exposure, and there's so much available, even on YouTube. I mean, I find incredible videos which are inspiring and which I learn a lot from, by watching that or listening to podcasts, etc. So I think there is. Then, of course, if you want to become very specialized, you have to go in and do a proper course in that. But I think the first step is to enlarge your mind and try to listen to ideas from disciplines which are completely different. So if you're a history student, you should be listening to podcasts on physics and vice versa.
Ma'am, the next question is from Aditya. Ma'am, in your speech, you mentioned about in high-income group countries, only 1/4 of the population is getting vaccinated, and in low-income group, it's around 1/500. And ma'am, you said that this principle of equity is the very basic principle of science and research. Ma'am, recently, India and South Africa raised the IPR issue over vaccine data in the World Trade Organization for the dilution of the intellectual property rights, so as to make vaccine data and technology available to the underdeveloped countries. This question is simple. Can't the IPR rules be waived off over the vaccines for the public good when the entire world is suffering at the hands of the pandemic? And wouldn't it also encourage innovation and research?
Yes, very good question. And that's what we've been also saying. We're supporting the call by India and South Africa for the waiving of the intellectual property rights so that the TRIPS flexibilities are actually become, the normal part of the way of doing business during the pandemic. And it's only for the pandemic. And so I really think that should happen. These things, happen by consensus at the World Trade Organization, and countries have not been able to come to a consensus because of the resistance from some countries which have big pharma and which want to protect the private sector by saying the argument that they give is that this will kill innovation and that the benefits of innovation must go to the companies which have invested in R&D. While that is true, that yes, if you invest in R&D, you should also get some benefits from it. But when we're talking about a pandemic, we're talking about people dying, millions of people dying. We're talking about the global economy suffering so badly. And the fact we know the global economy cannot recover unless all countries and all people are protected. In this situation, it's really very strange to see that people would not want to do this effort. And so what we are trying to do is work on several tracks. One is, of course, the intellectual property waivers. But even without that happening, we think we can make a difference. And that is by encouraging the technology transfer from companies or academic labs, institutes which have the technology, let's say mRNA platform technology. There are, let's say a dozen places around the world which have that, which have successful mRNA technology. Now, we have put out a call just yesterday for companies who are interested in sharing that technology to come forward and work with us. We will also identify in lower middle income countries the hubs which can uptake that technology. Let's say on the whole African continent, you hardly have any vaccine manufacturing capacity at all. That's one of the problems. So the whole continent of Africa is now dependent on importing vaccines. A lot of them go from India. But they need to build that because to have regional health security, every region in the world needs to have manufacturing capacity. So that's, I think, our next big focus and challenge is going to be, how do we do that? It's not something that will happen overnight. We need to train the workforce. We need to get infrastructure in place, investments in place. We need to have the regulatory environment in the country. We'll work on in parallel on all of that, but it is doable. And I think for the world as a whole, it will also benefit for future pandemics and for other diseases. Africa, if they develop their own, and mRNA technology is very versatile. It can be used for a number of different infectious diseases, but also for things like monoclonal antibodies, for cancer treatment and so on. So again, if you take cancer treatment, huge inequities that exist between the kind of immunotherapies that are available to people in high-income countries and the kind of treatments available in. So if you look at mortality due to cancer, it's so different in high and low-income countries. So there are many such. It's not just COVID-19, but the inequities that affect health. And so that needs to be changed through the investment in the right kind of expertise. Intellectual property is one part of that, but intellectual property alone, even if tomorrow the TRIPS waiver goes into force, we still need the know-how and the technology. Because it's drugs and vaccines are a little different. For medicines, the Indian generic companies were able to find their own pathways and their own processes to make those generic drugs. For vaccines, it's not that simple. You need the technology that's taken years and years to develop to be transferred. So that's going to be the focus of WHO as well as the COVAX partners over the next few months.
Right. Thank you very much, ma'am. I think that brings us to the end of this discussion, and I'm sure that all of us are going home learning a lot of things that we probably did not know an hour earlier, and we are very glad that you could join us here today. So that's it, and I would pass back to Shelly to end the session. Shelly.
Thank you, Shabdata. Thank you, Arnav. Thank you, Dr. Swaminathan. This was indeed a very enlightening and informative session. I'm certain that all of us have greatly learned from your insight into the scientific sector, its infrastructure, and of course, the progress of it. So this brings us to the end of the third session of Campus 2021. I would like to ask Dr. Shankar Kumar, Bursar Hindu College, to deliver the vote of thanks.
Thank you, Caucus. I hope I'm audible. Can I get some affirmation from your side? Yeah, okay. Thank you, Caucus, for organizing this lovely intellectual feast of sorts over the days and maybe I should say years. We have almost come to realize that it's an honor to be invited over to this platform and do some bit, even ask question. I'm sure Dr. Soumya Swaminathan, our guest today, should be a little bit less terse in terms of the desideratum that she hinted at, that we don't ask right fundamental research questions. Most of the attendees here are undergraduate students, and I found the questions to be very, very piercing and very good. As a teacher, I would certainly love to be in the middle of such questions. And the sweet, lovely smile on Dr. Swaminathan's face that I can see is an affirmation to the quality of the audience today. And thank you, Caucus, Shabdita, Arnab, Shelly, and your team. You have done a fantastic work. And what a lovely speech it was, what a lovely presentation it was. I entered into this anticipating some hard science because we had got used to seeing Dr. Swaminathan over the last 1 year, particularly around the beginning of the pandemic, on prime time television debates where she would so emphatically talk about the need to up the testing and bring it down to 5%, the positivity rate. At that point of time, it baffled us as to what is this about? I mean, what more number of testing will do? I'm talking of April, May days 2020. And very soon, see how pandemic teaches us. We got so socialized to these, these fundamental epidemiological principles or prescriptions that now for an average Indian, not trained in hard sciences, they would also appreciate what testing is all about, what upping the number of testing is all about, and so forth. So, your presentation dabbled into ethics. You talked about fundamental domain expertise, the requirement of it, the interdisciplinary aspect of it, and just do a little bit of positional overreach and say something about Shabdita's questions related to history. You talked about the inadequacy of top-down approach, need for the researchers to go to the fields, the actual ground zero situation, and get socialized with it. The embedded equity in researches and even in the solutions offered, and the role of the Indians in this, in terms of making some of the prescriptions very affordable. So it was completely a kind of 360-degree treatment that you gave to this theme, and I think we are all very delighted that we could listen to this presentation and learn more. Just one comment related to, as a teacher, I can't resist this because Shabdita is a history student and she did pose this question related to history. So just give me 1 minute, Shabdita. You spoke about our historical tradition or whatever is bequeathed to us through history in terms of it being a facilitator or some kind of a hindrance in the kind of scientific temperament that we need to have, which is a requirement of the time, of course. I would say that Dr. Swaminathan did speak about interdisciplinarity, and you get some fantastic specimen of interdisciplinarity in some of your ancient texts. Vagbhat happens to be one of the compilers of the iconic Charak and Shrushruta Samhita, the classical treatises of Indian medicine, what we popularly know as Ayurveda, now Neo-Ayurveda. He was writing sometime around, say, 7th century CE. And if you look into the details of it, he gives you very hard mathematical formulae of combinatorics, whose more systematic elaboration could be had in a text which is separated from it, say, by good 500 years in Leelavatis. That's placed around 12th century AD. A hard text on medicine, using a hard input and formulae of combinatorics, 500 years prior to its systematic elaboration in a specialized text. And that tells volumes about the kind of interdisciplinarity in which Indian knowledge tradition was premised. Somehow, over the last 200, 300 years of very compartmentalized, domain-specific, interventions, we have compartmentalized everything. And I think there is a lot of leveraging that we can do with respect to that historical tradition by upping our interdisciplinary quotient at this point of time in Indian academia, or for that matter, the world over. So that was just, as I said, that positional overreach. I have to give a vote of thanks, and it was fantastically done. Thank you all. It was wonderful. And I think there are other events lined up, and we look forward to that with the same level of eagerness as we did for today. And thank you again, Dr. Soumya Swaminathan, for giving this wonderful presentation. Thanks.
Thank you, sir. Thank you so much, everyone, for joining us today. For the knowledge of our audience, the transcript of this conversation will be available at our website, and you can find us at www.caucushindu.in. So that's it from our side. Join us again on 20th of April, where we are in conversation with the chairman of PM's Economic Council, Mr. Vivek Devroy.